Hello everyone, and welcome to our section on machine learning. In this one, we're going to have a brief look and overview of the scikit-learn library, and then apply it to an example where we'll predict the survival rate of passengers who were on board the Titanic. Scikit-learn is an open source machine learning library for Python that is used to implement machine learning models as well as carry out statistical modeling. The main focus of this course is on data analysis, so we're not going to go into too much detail on every aspect of machine learning or all of the different algorithms. However, it is still something that I wanted to introduce, as it might be an area that you'd like to move into. First off, if you're not using Anaconda, you can install scikit-learn with pip install scikit-learn with a hyphen separating scikit-learn. If you're on Conda, the command is conda install scikit-learn. However, this library does come with Anaconda by default, so you shouldn't need to install it manually. Before we move on to our example, let's have a look at what machine learning actually is. Machine learning is a branch of AI that allows a machine or computer to learn and improve from experience. It does this by using algorithms to analyze large amounts of data to identify patterns and trends without the need for explicit instruction or programming. There's lots of current real-life examples and uses of machine learning, but of these, the most relatable and commonly used applications are given here. So things such as facial recognition, email spam detection and filtering, product recommendations such as what you'd get from Amazon, or TV shows or movie recommendations from Netflix, for instance, all use machine learning. I won't go through all of these because they're listed here, but it's just to show how prevalent and widespread machine learning is within the modern world. And it's even now becoming a very useful and powerful tool in healthcare to predict health issues before they even happen, as well as climate modeling too. There's three main types of machine learning that we need to be aware of, and these are supervised learning, unsupervised learning, and reinforcement learning. Starting with supervised learning, these are algorithms that learn from labeled data, where the algorithm is trained on input and output pairs. Labeled data consists of examples with the correct answer or classification, and then learns the relationship between them. The trained algorithm or machine can then make predictions on new unlabeled data. This type of machine learning is commonly used for classification, such as spam detection, and regression, so for things such as predicting house prices, for instance. Some example algorithms include linear regression, logistic regression, support vector machines, and neural networks. But don't worry about knowing what all of these are. You really won't need to at all for your work as a data analyst, but just to let you know, in our example that we'll look at in this section, we'll be using logistic regression, so make sure to remember the definition of and purpose of these algorithms, because it will be relevant to what we'll be working on. Unsupervised learning, on the other hand, is used for data that has no historical labels. The algorithm needs to find patterns, relationships, and structure within the dataset without any explicit guidance or knowledge of the correct answer. Good use cases of unsupervised learning include clustering, so for instance categorizing or segmenting data, and also identifying outliers, as well as dimensionality reduction. Some example algorithms include k-means clustering, hierarchical clustering, and self-organizing maps. Finally, Reinforcement learning learns through interaction with the environment via trial and error, receiving feedback in the form of rewards or penalties. It's often used for robotics, gaming, and navigation, and common use cases include autonomous vehicles, robotics, algorithmic trading, and supply chain optimization, with some common algorithms including Q-learning and deep Q networks, or DQN for short. As we're going to focus on and use supervised learning in this section, I wanted to go through and explain the process that supervised learning follows, which looks something a little like this. Let's walk through what each of these steps entails. To start, we need to acquire our data. The data that you collect will be very specific to the project or industry that you're working in. But for example, if you're working in manufacturing, you might need sensor data relating to temperatures or flow rate, or in retail, you might need information on transaction data, inventory data, and you could even factor in data for global macroeconomic information, such as inflation figures for different countries, or different measures of economic performance. There's so many different examples and possibilities for these, so I'm not going to go into them all, but the important takeaway is that this data could come from a variety of different sources. Then we'll clean, prepare, and format our data into a structure that can actually be processed and worked with by our machine learning models and algorithms. For the vast majority of cases, we'll use libraries such as pandas to do this. Then we'll carry out any feature engineering that we need to do in order to create other variables that our model can use. A good example of this would be when we created our two categorical age columns in our data cleaning example in Excel and Python, where instead of just having the age, we created two new columns, which were for if the age was greater than or equal to 55, and also less than or equal to 25. At this point, we'll then split our data into training data and test, or sometimes as it's called, validation data. We'll explore this later on, but essentially, all we do here is take our entire data set and split it up into data that we'll use for training and building our model, and then data to test our model and see how well it performs. The optimal ratio for this depends on several different factors, but a very typical and average ratio or split would be around 70% for your training or model building data and 30% for your test or validation data. After we've created and trained our model, we then test it to see how well it performs, using our validation data and the trained model to do this. We put the test or validation data through our model and then compare the model's predicted results to the correct labeled data from our validation data. At this point, if we're happy with the model and how it's performed, we can deploy it, or alternatively, we can go back and further tune and configure our model. So this is a pretty simplified overview of the process, and there is of course much more detail to each step, but we'll see all these steps and actions carried out over the next 2 lectures, where we'll work through our own machine learning project. As we work throughout the process, just think back to this process map, and hopefully it'll make it easier for you to understand and see what we're doing at each stage. Thanks everyone, and I'll see you all back in the next lecture.